In this video, we are funding the work done when we are pumping water out a cylinder tank. So the question asks, a cylindrical tank of radius 4 meters and the height of 10 meters is filled to a depth of 8 meters. How much work does it take to pump all the water over the top edge of the tank? So the first thing we do is label all the variables. So we know the radius is 4 meters, and we know the height is 10 meters, and we know the water depth is 8 meters. The next thing we need to do is label X. So we're going to label X from the top of the cylinder from the bottom, going downwards to the bottom of the tank. There's a few things we need to know to solve this problem. We need to know the density of the water, which is 9,800. That's the density. And we need to know the area of the top, which is a circle. And we find the area with pi r squared. That is the formula for circles. And we need to integrate the volume of the water. So we need to find the top end of the integral, which is 10, which is the length of the cylinder. And we need to know the lower end of the integral, which is 2. So we get 2 from subtracting 10, the height of the cylinder, from the depth of the water. So that would be 2. So the water ends around here. So this would be 2. So this length right here would be 2. So we also need to approximate the layers lifted from the pump, which is x dx. So we put all them all together. So we got 10 over 2. So we got 9,800 pi. Let's go ahead and put the radius is 4. The radius is right here. And the x dx for the layers being pumped. So we have a lot of constants. We have a constant of the density. We got a constant as a pi. We also got constant at 4 squared. So we could put all of that in the front, and we're gonna go ahead and square the 4. Go ahead and put 16 times 9,800 pi. So we got x dx, and we combine that together, these two. So we multiply 16 times 9,800, which is 156,800 pi. So we need to integrate the x. So we integrate it by, so it's x squared divided by 2 times, we need to time these together. So we got 10 on top and 2 on the bottom. So we need to do that at every step. So we got another constant here, 1/2. So it actually looks kind of like this. So we can go ahead and move the other constant, the 1/2, to the front as well. So we got 156,800 divided by 2 pi. So we got x squared right here. So we input the top end and the lower end of the integration. So we have 10 squared minus 2 squared and let's go ahead and simplify this. So we got 78,400 pi times 100. We're going to go ahead and square it right now. Minus 4. So go ahead and subtract this. So 96 times 78,400 pi. So we multiply pi 96 and 78,400. And that would be 23,644,882.95 joules. And that is it. That is the answer.